Let's discuss the concept of electric field lines or electric lines of force. Right? So can you tell me what these electric field lines are? Are they real? No, right? They are imaginary. So imaginary lines or imaginary curves, can I say? Right? Just because we use the word lines, it doesn't mean they are lines, they are actually curves. Right? Imaginary curves around the charge distribution. Right? Now what do they do? What do they signify? Which? They give us the direction, right? Direction of whom? Direction in which? That sensor. Direction in which the test charge would start moving. Right? So, which gives us the direction in which test charge starts moving. Right? In which the test charge starts moving. So, when I talk about the properties of electric field lines, first thing, what is that you observe? They are always for an isolated positive charge. For an isolated charge itself, for positive charge, how was it? How are the field lines? Was it towards or away? Away. So, they are always away from the positive charge. Then what about the negative charge? They are always towards the negative charge. Second point. What about the third point? So what about the third point? When you had a system of unlike charges, what happened? They were away from the positive charge and towards the negative charge. Where did they start and where did they end? They started from the positive charge and they end with the negative charge. Right? They do not form a closed loop. They start from positive charge and end with negative charge. Am I clear with this? Right. They start from positive charge and end with negative charge. Right. So if you're done, I'll open another slide. Done copying this? Right. So what is the fourth point? They do not form what loops? They do not form closed loops. We'll mention this point. Unlike magnetic field lines. So they do not form a closed loop unlike magnetic field lines. Fifth, suppose, observe this. Suppose I have a system like this, positive and negative, for us to understand. It starts from the positive and ends with negative. Am I right? Now the question is, if I want to find the direction of electric field at a given point, how do I do that? What you need to do is, at that point, draw a tangent. But here where the question comes. So when I talk about a tangent is a line which touches the curve at one point. That's what mathematics tells. Right? So how can the tangent give me the direction? Is it going to be in the rightward direction or leftward direction? I don't know. So you need to draw the tangent in the direction of the curve lines, right? So you need to draw the tangent in the direction in which the curves are actually moving. So to consolidate and tell you, we can say the tangent drawn to the curve at a point gives the direction of electric field, right? So tangent drawn to the electric field line at a given point, what does it do? Gives the direction of electric field at that point. Make sense? Right? We need to draw the tangent in the direction of it. So this is going to be the direction of electric field line. Right? And the last point is, no two field lines will intersect each other. Why? So this field line and this field line, let's say they both are intersecting each other, then the meaning of it is, at a given point, listen to this carefully, at a given point I can draw two tangents. So when I draw these two tangents, what is the meaning is, if I place a test charge here, we are trying to say that the test charge is moving in two different directions simultaneously, which is not possible. Unless it is broken into pieces, right, it cannot move in two different directions at the same instant, right? So this is a very, very, very important point and often asked question. Why do the field lines never intersect? So what will be the answer that you will write? We need to say that we can draw two tangents at the point of intersection. So two tangents can be drawn at the point of intersection. And what does it signify? Which indicates what? The test charge can move in, which indicates the test charge can move in two different directions at the same instant. Am I right? At the same instant. So what will be the conclusion? Which is not possible. That's it. Right? So this explanation, as I told you, is very, very important. This is often asked.